Hello, so how are computers save negative numbers? Isn't it interesting to know? So, if you think about positive numbers, it seems to me very simple thing. So that's why we are just discussing negative numbers. But yes, while going through this video, you will also come to know about the positive numbers a bit, but the main focus would be negative numbers only. Okay, so before diving into any specific examples, we need to understand the processor type for any computer. So computer can come with 32-bit processor, 64-bit processor, or maybe any other variety. So if we have 32-bit processor, then we have the range from 0 to this number. This number is coming from when you do 2 power 32, then this will give us this number. So that much range we will have for saving the data or representing the data. And similarly, if we talk about 64-bit, similar to 32, if we do 2 power 64, then this will give us this huge number. So basically the idea is like if we have 32-bit or 64-bit, it will directly affect the performance. So 64-bit will have a high performance, obviously. Cool. But this is humanly impossible to deal with this large number. So that's why I have taken an example of 8-bit only. So which means that our processor is of 8-bit, which means 2 power 8, so which is equal to 256. If you calculate it, you will get 256. So which means that we will have numbers range from 0 to 255, right? It's not from 1. That's why at the end I have 255. Cool. So what does this mean? So all the numbers will be in this range. So is it like negative numbers also come in this range? So I don't know, like where are the negative numbers then? This is a interesting question and this is an interesting part to know. So basically the idea is like half of the numbers will be positive and half of the numbers will be negative. So in 8-bit system, the maximum possible positive value will be 127 and all the other will be negative number. Let me show you some examples. So before going into specific example, we need to understand the binary format that is used by a computer to save anything. So basically we have 8-bit system, that's why we have a range from 0 to 7. If you see 2 power 0, 2 power 1 and up to 2 power 7. So why it's 2? Because we are considering binary format, so which having only 1 or 0, that's why the base is 2 everywhere if you see. And the below line is just calculation of above line. So 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4 and so on and so forth. 2 power 7 is 128. Okay, so here I just repeated that representation to have a clear picture in our mind. So let's take an example of positive number first. Let's take an example of 1. So how the 1 can be represented in this format? So basically the numbers which are contributing to make this 1, so we're gonna set those bit. So here if you see, the 1 is something which can contribute to make the number 1. Basically we will do sum the numbers if they are set. So all the others numbers will be 0. So okay, so which mean that we will have 1 if all the other bits are 1, or other bits are 0 and the last one is 1. So similarly if we see the 2 2, then what we're gonna do here, we just change it to 1 and change it to 0, then we will have 2 as the answer because 2 is set now, right? So we can write it like 1 here and 0 here, the answer will be 2. Or to make it more clear, we can write it 2 as well because it has the value 2, that's why I just wrote it here like that. So for 3, this bit will be set as well. So 2 plus 1, 3. So positive numbers are very simple and it's clear, I think. So now we are ready to deal with the negative number. So let's look at that. So now let's see that how 255 is represented. So because we have a range of 255, that's why I have taken an example of 255 now. So here, if we see 255, so because I know that if I set all the bit, then I will get 255. So if you want to validate this, you can add all the numbers here and you will get 255. So which mean that if all the bits are set, then we will get 255. Or you can say like this as well, because if you see the value of each bit is 128 plus 64 and so on and so forth, so you will get 255. But this number is negative, right? Because we have seen that half of the numbers are only positive, that is from 0 to 127. Then this number must be negative. So there is a one bit which is a sign bit. The sign bit, I mean that this particular last bit, which is the last bit is like, if it is set 1, that means it is a negative number. If it is set 0, then it means it's a positive number. So if it is 0, then what we're gonna do? We just count all these numbers, right? So what we will get? We will get 127, which is the maximum range. So because the positive number, the last positive number is 127. So if you will sum up everything, 0 plus these everything, you will get 127. Like this. If you do this 0, then it will be 127. So which means that if you do the same thing again, so it is minus 127 because it's a sign bit. So what you will get? You will get minus 1. You can do calculation, you will get minus 1 here. So basically we can say that minus 1 is equal to 255. Or you can say that 256, that is a total number. Here you can see 256. And if you plus the number, you want to see the representation, because minus 1 is that, so you will get 255. And similarly, if you want to see the number minus 2, how it is represented, and 256 plus minus 2, which is 254. So basically, sometimes there are few uses then that you want to see the positive number instead of the negative numbers. For example, if you want to convert the decimal number into hexadecimal number, then it might be very useful to have the positive numbers instead of this minus 1. You can use 255 and then convert into hexadecimal. It's pretty simple if you do this sort of calculation. Okay, so that's it for this video. I hope you find it informative, and if you like this video, so please give it a fat thumbs up and share, like and subscribe. Thank you.